So hi guys, welcome back, and my name is Samir Kumar and I'm back with another deep learning machine learning video. And in this video we'll go through a transfer learning approach using VGG16 where we'll try to uh, 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 classify the particular images of cars, be it Audi, Lamborghini or Mercedes. So we have three categories in our data set over here. Okay, so as we know, basic of transfer learning, where we're going to use the pre-trained models that were basically a group of researchers once came together and actually found out this architecture. So we're going to use this pre-trained models, pre-trained parameters, and we're going to create our own model. So that is a basic concept of transfer learning. So let's begin. So we'll go through the basic code and understand the basic general template that we use. So as we know that any architecture, any image classification architecture over here is basically an extension of a convolutional neural network where we use the layers of convolution and max pooling and applying activation function, extracting those properties and all those things. The first step is basically importing the required libraries. That is okay. You can use TensorFlow, Keras, whatever you wish to use, depending on the version. Now, second step is to first resize all the images size. Okay, so first you have to specify the image size that is 224 cross 224. So as we know, that according to VGG16, the standard size that is generally used is 224 cross 224. That's why we have used it. We can use any size as well. There's no issue with that. You provide the training path and the testing path, the path that you have, the images wherever you have stored in a directory. So you have to provide that path. And the next step is to basically pre-train, load the model, whatever model you're using, whether VGG16 or Resident 50, whatever. In this case, since we have used VGG16, so the input shape will always be image size plus 3. Since we are using those RGB images, not black and white images, so you have to specify that plus 3 as well. Weights will be always ImageNet because, as I said, we are using the pre-trained model, which is already trained on the ImageNet dataset. So we're going to use those weights and include top is equal to false. Basically, we are not going to use the last layer of that architecture because understand that VGG16 is basically trained on 1000 categories, but our model is not going to train on 1000 categories because it has only three categories. So we're going to remove that bottom layer and the top layer, because we can use any image size at the top and we have to remove that bottom layer. So that's why we have used is equal to false. So this is the summary. As you can see, you don't have the last layer as of now because we've removed it. Okay, so this is the VGD.layers. It will show all the objects that have been created, all the 16 layers objects. Now you have to iterate through those VGG.layers and you have to show that layer.trainable is equal to false, because we don't want to retrain those weights. We are simply just going to pick those weights up from the pre-trained model and we're going to use it over here. That's why we have done that. Now, as you can see, we have used the glob function so that we can first get the categories that are there in our folders, right? Audi, Lamborghini, and Mercedes. Based on we have only three categories, so we're going to store it over here because we have to provide those number of categories in the last layer. That's why we have stored it over here. So if you see VGD.output, so it will show you the output whatever the last layer would be in that way. As you know that the architecture of VG16 is basically a 16 layer architecture. So in the last layer you have the output layer, and then you have to flatten the output, right? You cannot just give the output matrix to the model or to the neural network. You have to basically flatten it and then give it to the neural network. As you know, the architecture, hidden layers, input layer, and then the final layer, right? So now you find out the predictions, and as you can see, we have used the activation function as softmax because we have three categories over here. If it would have been a binary classification, we would have used sigmoid activation, but over here we have to use the softmax activation function. Then you have to create the object of the model where you'll give the input as vgg.input and outputs will be a prediction. That's why we first found out the predictions over there. You have to create the dense layer, right? Dense layer is basically the last layer, whatever the layer you're gonna treat it as the output. So over there, the length of folders will be the basically output, because those many number of nodes you want, three nodes you want. So as you can see in model.summary, you can see the last layer being added over here. Then you're just going to use the model.compile function. We're going to use the loss is categorical, cross entropy, and optimizer as Adam. The matrix is accuracy. Then you use the image data generator, where you're going to use the concept of data augmentation, where you're going to apply a certain techniques on training data sets. You're going to increase the number of images internally. That is the concept of data augmentation. You're going to rescale those images, normalize those particular images, and you're going to call the data set. It is basically used to read the data set from your folders, and you're just going to train the data set, and you're going to apply epochs as 20. You can use for multiple epochs to increase the accuracy, and as you can see, I got the accuracy as validation accuracy as 87%. You can try it with other epochs as well. So yeah, thank you guys. This was it from my side. I'll post the medium link in my description below and other links as well. Thank you.